All right, in this video, I'm going to go over graphing rational functions. Now, it's just kind of a guesstimate of what the graph looks like. So, first of all, in order to know kind of what it looks like from a toolkit function view, we look at the degree of the denominator, and you kind of just add up the exponents. So there's an understood 1 there. So if there's an odd degree in the denominator, that means it's going to look something like this. All right? At least that's the end behavior. If it's an even, what am I doing there? If it's an even degree in the denominator, it would look something like this on the ends. Emphasize on the ends, because in the middle, we're going to have 2 vertical asymptotes, and something in the middle is going to happen. All right. So vertical asymptotes, that would be found by taking the terms in the denominator and setting them each equal to 0 and solving for x. Square root of 0 is 0, plus or minus 0, so x plus 3 equals 0. But they cannot be those numbers, because if they were, then the denominator would be 0, which is irrational. So I put x cannot equal -3 and x cannot equal 2. So those are our asymptotes, the vertical ones anyway. Okay. I mentioned no, I didn't mention. All right, so next part is the x-intercepts. The numerator actually tells you where the x-intercepts are. So we set that equal to 0 and that equal to 0, and we get -1 and +3. Not bad. And there's a horizontal asymptote here as well. The degree in the denominator is equal to the degree in the numerator. So what happens is we just take the coefficients, the ratio of the coefficients. Now, you don't have to completely FOIL them out, but you have to think about what would that first leading coefficient be if you did FOIL them out. And it's pretty easy because all these are 1s, understood 1s in front of all these x's. So it's just going to be 1/1 is our horizontal asymptote, or y equals 1, or y cannot equal 1. Now, I am leaving out the middle part because for some reason it doesn't apply to the middle part. All right. Now, since our x-intercept is down here, we know that our graph is going to be going this way. And since we don't have an x-intercept over here on the negative side, we know that the graph must look like this over here, right? And the denominator is degree is odd because it's 3, right? So it's going down to the right and up to the left. Got it? Now, what's happening in the middle? Well, usually it might do like a up one way and down another way, but we got to make sure. So first of all, what's our y-intercept? What do you get when x is 0? Well, you get 1 squared times -3 in the numerator and 3 squared times -2 in the denominator. -3 over 3 squared is 9 times -2 is -18, right? And that would be positive 1 over 6. So about 1/6. As we approach this asymptote, we get closer and closer to -3, right? So what, -2.9 plus 3 is a positive number squared, and negative, that's a negative, so the denominator is negative. And -2.1, it'll be eventually squared, so it's going to be positive. Negative something minus 3 is also negative. So all I did there was figure out if the numerator was going to end up negative or positive. And same with the denominator. And they're both negative, which means the whole thing is positive. So we can assume that this is going up, right? But just because that part's going up doesn't mean that that part's going up or it's going down. It could be either way. So we do that same thing, but with the other side, with positive 1.9, right? That's always positive. 1.9 to -3 is still a negative. That's always positive. 1.99 minus 2 is still just barely negative. So that would also be positive. So we have a parabola in the middle. See how I did that? You just kind of got to think through things without actually having to do math. Kind of nice. But the graph just kind of touches the x-axis here. It doesn't cross it, it just touches it. It's very important. Now, there is a way to know before doing that whether an x-intercept touches or crosses it, like it does here. Now, it crosses here because the degree of that 0 is an odd number. The degree of this 0 is even, and so it just touches it. That's how you know. All right, second example. We'll call it good. The degree in the denominator is odd again. And our what are our vertical asymptotes? -1 and +2. Just taking shortcuts, you know, nothing wrong with that. Okay. X-intercepts, +3, 1, 2, 3, and it goes through it, and -2, and goes through it. Y-intercept, put a 0 in for all the x's, so 0 plus 2, 0 minus 3, 0 plus 1, 0 minus 2, right? 2 times negative 3, negative 6. 1 times negative 2. So positive 3 is our y-intercept. Okay. Now, there's no x-intercept in between the asymptotes, so we can assume that this is some sort of parabola here in the middle that never crosses the x-axis. Now, what about the ends? It's an odd degree on the bottom, but which one is which? They both cross. Do we have a horizontal asymptote? The degree in the denominator is larger. Whoa, so our horizontal asymptote is y cannot be 0, except we have these x-intercepts clearly. I think the y cannot be 0 only applies to the middle part. And what happens is these graphs cross, and then they kind of just hug the line, that asymptote. Right, as we get closer to negative 1.1 plus 2 is positive. Negative 1.0. Negative, that's a larger negative than the positive, so the numerator is positive. And down here, negative 1.1, that would still be negative, but it would always be positive. And still negative. And it's a larger negative than that. So that would also be negative. So it does go in the positive direction there. And I don't know, negative 100 be negative. Negative 100 is also negative. So that would give you a positive on the top for as x approaches negative infinity. Negative 100, that's always positive. Negative 100 is much greater positive than it is negative, but it is a positive times a negative, so we get negative. So it is below the line. So yeah, explain to me why that asymptote actually gets crossed. That's fine. And since it's odd, it's an odd degree in the bottom, we can assume that the graph does that. Maybe not like that. A little sharper there. Yeah. And there you go. Please check my math.